Okay, so in this question, we've been asked to balance this equation. We've got potassium chlorate reacting with white phosphorus, P4, and that produces phosphorus pentachloride and KCl, potassium chloride, right? So how would I approach balancing this equation? Well, the first thing I'm going to do is I'm going to take a look at, well, how frequently does each element occur on both sides of the equation, the reactant side and the product side of the equation, right? So here we've got potassium, we've got chlorine, oxygen, and phosphorus, right? So I'll start with the left-hand side. So we've got potassium, chlorine, oxygen, and phosphorus, okay? And in terms of potassium, you can see this only occurs once, and it's in the KClO₃, so that's just going to be a 1. Chlorine, again, it occurs once. For oxygen, we've got O3, and it doesn't occur in the white phosphorus, so that's going to be just 3. And P for phosphorus, we've got just P4, so that's going to be 4, right? Okay, so now in terms of the product side of the equation, so the right hand side, RHS, we've got, in terms of the potassium, it occurs once, right? Chlorine once, oxygen 10 times, right? And the phosphorus 4 times. Right, so if we look at the left hand side and the right hand side, what do we find? Well, we find that for the potassium and chlorine are quote unquote balanced, and the phosphorus, but the oxygen clearly isn't, right? So we have to consider how we can try and get them to a point where they are equal, and it's not very straightforward, because I mean, although we could try and put like a, for example, 3/10 in front of something, or some, or some kind of weird way of doing it like that, it's something I would want to avoid. What we're going to try and do in this instance actually is, rather than adding only one number to one thing, I'm going to add 2 numbers, right? So I'm going to look for effectively the in essence, we're really looking for the lowest common multiple here, which for both 3 and 10, if we're looking at 3 and 10, the lowest common multiple, obviously 10 goes 10, 20, 30. We know that the lowest common multiple is 30, right, between 3 and 10. So in order to balance out the oxygens, I'm going to take both of them up to that lowest common multiple, right? But the way of doing that would be on the left hand side, I'm going to multiply the oxygen by 10, which is basically by putting a 10 in front of the KClO₃. On the right hand side, I'm going to multiply the oxygens by 3, which is by putting a 3 in front of the P₄O₁, okay? And by doing that, both of them would reach 30 in terms of the oxygen. But because it's mixed with other elements, there's going to be some other consequences to doing that. So this is what we're going to go and see what's going to happen. So anyway, when I do that, let's look at what the new equation is going to be, right? So that's therefore going to be 10 KClO₃ plus P4, and that goes to produce and here we're going to put the 3, right? So 3 P₄O₁ plus KCl, right? So let's audit this now and see where that has arrived us. Okay, so if we do that, so for phosphorus, you can see it's 10 times the K, right? So we're gonna have 10 phosphorus. For Cl, it also occurs once originally, so it's 10 times 1, right? So it's gonna be 10. And for the oxygen, it's 10 times 3, so that's gonna give us 30, which is what we're aiming for the oxygen. And for phosphorus, we didn't really put anything in front of it, right? So it's just gonna be 4, just as it was before. And we did make modifications to both the left-hand side of the equation and the right-hand side. So for the right-hand side as well, so if we consider what the outcome is for the potassium, we didn't put any number in front of the KCl, so that's going to literally just be the same as what it was before. It's just going to be 1. For the chlorine, it's going to be a 1. And for the oxygen, it's going to be 3 times what it was for oxygen, so that's going to be 30. And 3 times the P4, that's going to be 12, okay? So this is effectively what we get so far. And you can see at this stage, the oxygens are balanced, but the chlorines are not, the potassium is not, and the phosphorus is not. So there's quite a number of things to balance at this stage. But because we have the phosphorus on its own, I'm going to make a choice. I'm going to choose to leave it to the end, right? So it gives the flexibility to, it's much easier to modify the phosphorus if need be at the end on one side than trying to modify it before everything else is kind of balanced to the extent possible, right? So, okay. If we look very carefully at one of the key imbalances here, the potassium and the chlorine, what you notice is that you've got 10 on this side and 1 on this side. Now, fortunately for us, actually KCl, as you can see, is got the 2 elements on their own together. So we can resolve that particular imbalance on the by adding a 10 in front of the KCl on the right hand side. So if we do that, and let's take a look at the new equation that we got, right? So 10 KClO₃ plus P4 produces 3 P₄O₁ plus 10, right? KCl. Okay. So let's take a look at auditing this. Let's itemize effectively what do we have in front of us? What do we have in terms of the occurrence of the elements, right? So on the left hand side, we didn't change anything, right? So this would be exactly the same as what it was just previously. But on the right hand side, we added the 10, right? So that's going to affect the potassium and it's going to affect the chlorine. And more specifically, it's going to increase those from 1 instead. It's going to increase them to 10 times 1 for that, and again 10 times 1 for the chlorine as well. So and these, we didn't change anything here, so this is basically going to be the same. We're going to have 12 and 3 times 10, right? So 30. So now, as you can see, the only thing that's now unequal between the right hand side and left hand side is the number of phosphorus, right? But because we left that to the end, specifically because the phosphorus, as you can see on the left hand side, is on its own, it's quite straightforward to resolve that particular one, right? So if we simply put a 3 in front of the P4, obviously that multiplied, 3 times 4 would give us 12, right? And so if we do that, we get 10 KClO₃ plus 3 P4, and that produces 3 P₄O₁ plus 10 KCl, right? Okay, so with what we've got here, if we now do the auditing process again, and we didn't really change much, we just changed this, right? Out of everything, we just changed the number of phosphorus, KClO₃. So that's going to be, of course, that's going to just be the same. It's going to be 10. It's going to be the same again. It's going to be 10. Oxygen is going to be the same. For phosphorus, is going to be, instead, rather than 4, it's going to be 3 times 4. So it's going to be 12. And on the right hand side, in this particular step, we didn't do anything to this side. So it's literally, as you can see, it's just going to be the same numbers we calculated, right? Because it is literally the same thing. So that's going to be 10, 10, 30, 12. So if we now compare the left hand side and the right hand side, as you can see, we've got the same number of occurrence in terms of each of the elements, right? So we can, and the other thing, right, as the question does specify, it says we should use only whole numbers when balancing the equation. So in our final equation that we've got here, we've got only whole numbers that we've used, so that adheres to that particular requirement as well. So we can say that this is our balanced equation, right? So here we can put those numbers in, right? So right, we could even add them up here as well if you wanted to. Okay,